Good morning, this is Bruce and welcome to my shop. Been a while since I've put up a video. This video today is one of the getter outs that I've got. I've got several and I've got to go out on site to do another one as well. I've got one over here, I don't know whether we can see it. We've got an engine block over on the milling machine that has a broken stud in it. And we have this roller which is off a printing press. The drive gear end here has two broken studs in it, or had two broken studs in it out of three that hold the drive gear. Now what I've got one out now and I'm about to do the second one. Now there's many ways we can go about this, but I want to show you the method that I used here, bearing in mind that the first thing is I like to have control of the machine that I'm using for doing the drilling and so forth. So I get it as sturdy as I can, as centered up as I can, etc. So this one I dialed it in from the chuck. I dialed it in and I've set the DRO for a 6-hole configuration, even though this is only a 3-hole configuration. And I've set the center, the top hole here, as the zero, as the number 1 hole, basically. And so that's my start point, and I'm doing holes 1, 3, and 5 for the removal, and then I'm going to do 2, 4 and 6 to drill and tap 3 more holes at 60 degrees to these ones, so they've got spare, so if they break a bolt while they're working, they can then take the gear off and turn it through 60 degrees and re-bolt it up again in the new threads, so that gives them some retention for future. Now, I like to use, when I've got a broken bolt, normally the head is jagged, so and these are deep inside. So what I like to do is go in with an end mill and try and get a face on it. If it's protruding out, I'll get a die grinder with a ball, and I'll use the ball to produce a center, which I can then center up and drill through. So don't want to use an end mill in this situation, so I've opted to use what I've got fitted here now. Come in a bit closer, we go down a bit. What I've got here is what we call a rescue bit. I'll show that up. Let me get this here so that it's I'll show you the bit. Now this bit is double-ended, has 2 ends to it. This one is a 1/4 inch, I'm using a smaller one. Now it's a carbide, 100% carbide. It's got like a drill head arrangement on it at the top with a couple of different facets. And it's also spiral, so this can be used for cutting out. You can actually cut with it as well. That all comes in the instruction sheet. The rescue bit instruction sheet tells you all about it. I won't go into that because it's very fine print. But anyway, that's the rescue bit, and I only use this on my milling machines. So this one's a virgin. I haven't used it. What I've used is this smaller one on the mill. Because I need to get smaller than the actual hole. The bolt itself is an M5. The bolt itself is an M5, and so I drilled through the first bolt. I drilled through with that small rescue bit, the 1/8 rescue bit, and then I drilled with just an ordinary twist drill, but this is the tapping size for the drill, for that same thread, and that pulled what was left of the thread out. So that all cleared up, and I went through with a regular tap. Now on taps, if you are going to repair a thread or try and capture a bolt that's broken in there on the thread and clean it out, do not use a full taper tap. Always use an intermediate one, the number 2, not the number 1, and not a butt tap either. You have more chance of capturing and getting it back out again. If you use a taper, it'll normally lock up and it'll break. So that's a little bit of useless information I can pass on to you. So we've been successful here. I'm not going to bore this video with all the work, but we've now got. I'll see if I can show that. Well, that's the hole in here, and I've cleaned it. I've totally cleaned it out, and it's good to go. I'm now going to go over to the one at the back here. I'll get that one out, and then I'll start drilling and tapping 3 more holes. Thanks for watching.